Ramanujan for G is now available on the Google Play Store. Try it out for free.
So today, first we'll look at one example based on the PNC. Okay, so let me start. Okay, the question given is in how many ways 20 identical mangoes may be divided among four persons. Divided among four persons if each person is to be given at least one mango, right? So then number of ways will be, okay, so given 20 identical mangoes may be divided among four persons, meaning you'll have to write 20 plus 4 minus 1 c 4 minus 1, that is 19 c3, that is equals to 19 c3, and that is 1771 ways. Now if each person is to be given at least one mango, if each person is to be given at least one mango, then number of ways will be what? So here you need to write 20 minus 1 4 minus 1, that is again 19 c3. Also it will be 23 c3, this 19 c3, so this is 969. So you can copy down this question. Given question is in how many ways 20 identical mangoes may be divided among four persons. If each person is to be given at least one mango, then the number of ways will be. So for the 20 identical mangoes may be divided among four persons. That means 20 plus 4 minus 1, C4 minus 1, that will be 23 C3. So that is 1771 ways. Now, if each person is to be given at least one mango, then the number of ways will be 20 minus 1 C4 minus 1, that is 19 C3. So it will become 969. Okay, so you can copy this question first. Okay, so now let's look at another question. In how many ways can a pack of 52 cards can be divided in 4 sets? Three of them having 17 cards. Three of them having 17 cards, each 17 card each, and fourth just one card. So here, since the card are to be divided into 4 sets and three of them having 17 cards, 17 card each, and fourth just one card, so that is 52 divided by 17 factorial 3, 3 factorial 1 factorial, so that is 52 factorial divided by 17 factorial cube into 3 factorial. Here again, we need to find in how many ways can a pack of 52 cards can be divided into 4 sets. So three of them having 17 card each and four just one card. So the card are to be divided into 4 sets and three of them having 17 cards each and fourth one is just one card. So you will write 52 divided by 17 factorial cube into 3 factorial into 1 factorial. Okay. You can later simplify this 52 factorial by 17 factorial cube into 3 factorial also. Next is de-arrangement theorem. I think this is de-arrangement theorem. So any change in the given order of the thing is called de-arrangement, right? So first case here, if n items are arranged in a row, then the number of ways in which they can be rearranged so that no one of them occupies the place assigned to it is. So that will be n factorial 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial, and goes on till minus 1 to the power and 1 by n factorial. And similarly, the second one is, if n things are arranged at n places, then the number of ways to rearrange exactly r things at the right places is. So that will become n factorial by r factorial 1 minus 1 factorial 1 by 2 factorial 1 by 3 factorial plus 1 by 4 factorial, and goes up to minus 1 to the power n minus r 1 by n minus r factorial. Okay, these two formula you need to learn. So the first one is for if n items are arranged in a row, then the number of ways in which they can be rearranged so that none of them occupies the place assigned to it is. Second is, if n things are arranged at n places, then the number of ways to rearrange exactly r things at the right places is. Okay. We will take few problems based on this. Okay. So problem, there are three letters and three envelopes. The number of ways in which all letters are put in wrong envelopes is. Okay. So let's solve this problem. So the required number of ways, the required number of ways, so that is 3 factorial 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial. So that will become 3 minus 1, that is equals to 2. Okay, next one more problem. There are 4 balls of different colors and 4 boxes of colors same as those of balls. Then the number of ways the number of ways to place 2 balls in boxes with respect to their color is. Okay, so meaning we need to, there are n things we need to arrange at n places, and the number of rearrangement we need to find at r things at right places, right? So meaning 4 factorial by 2 factorial 1 minus 1 by 1 factorial plus 1 by 2 factorial, that is 4.3. 1 minus 1 plus 1 by 2 is equals to 6. Okay, next thing is divisibility of numbers. Divisibility of numbers. Okay, so here I will write divisible by, and this size will write as condition. So you can draw a line. Okay, so let me choose a different color. Okay, so first one is 2, whose last digit is even. Next is 3, sum of whose digits is divisible by 3. Next is fourth one, whose last 2 digit number is divisible by 4. Next 5, whose last digit is either 0 or 5. Next for the sixth one, which is divisible by both 2 and 3. Next, seventh is not there. Eighth, you can take eighth, whose last three digits divisible by 8. Similarly, if we talk about the 9, that is sum of whose digits is divisible by 9. And next is 25, whose last two digits are divisible by 25. Okay, so these are some divisibility rules of given numbers. Okay, so we can copy down. Okay, next is sum of numbers. So for a given and different digits like a1, a2, a3 up to the an, the sum of the digits at in the unit place of all numbers formed, you can write a1 plus a2 plus a3 goes up to an n minus 1 factorial, and that is sum of digits n minus 1 factorial. Second is sum of the total numbers which can be formed with a given and with given n different things. So that you can write a1 plus a2 plus a3 goes up to an n minus 1 factorial, and that is 111 up to the n times. So the first one was for a given n different digits like a1, a2, a3 and up to the an. The sum of the digits in the unit place of all numbers formed, if the numbers are not repeated, this condition is given. So that will become a1 plus a2 plus a3 goes up to plus an n minus 1 factorial. That is the sum of digits into n minus 1 factorial. The second is the sum of the total numbers which can be formed with a given n different things a1, a2 up to the an. That is a1 plus a2 plus a3 goes up to an n minus 1 factorial into 111 n times. Okay, so this was for the sum of the total numbers which can be formed with a given n different things or n different digits. Okay, so I will take one example. Sum of four digit numbers formed with digits 1 2 4 and 6. Okay, so here you need to use the formula sum is equals to 1 plus 2 plus 4 plus 6 into 3 factorial into 1 1 1 1. So that is 13 into 6 1 1 1. So that will become 8 6 6 5 8. And there is second method also that also can be used. Here total 4 digits numbers will be 4 factorial, that is 24. So every digits will occur 6 times at every one of the 4 places, right? So now the sum of the given digits is 1 plus 2 plus 4 plus 6, so that is 13. So sum of digits at every places of 24, that will be 13 into 6, that will be 78. So now at first place 78, at tens place 780 at 100 place, 71800 at thousands place, that is 78000. So the required sum 78 plus 780 plus 7800 plus 7800. So it will become 86658. Okay, meaning first you need to find the total four digit numbers will be 4 factorial, that is 24. So every digits will occur 6 times at every one of the four places. Now sum of the given digits will be 1 plus 2 plus 4 plus 6, so that will be 13. So the sum of all digits at every place of all 24 numbers, that is 13 into 6, will become 78. So the sum of the values of all digits at first place is 7800, and at the thousand places 78,000. So required sum will become 78 plus 780 plus 7800 plus 78,000. So all will become 8,6658. Okay. So with this, we'll wind up the lecture here. So thank you guys. We'll see you in the next lecture.